Hi and welcome to Shrov's classes. Today we are going to be dealing with practical statistics. To be specific, the most important questions of practical statistics. You can WhatsApp or call us at the following number for any doubts or for full videos on our courses. Today we are going to be dealing with drawing of samples under stratified, linear, systematic and cluster sampling. Let's see the first question. If you want to draw a stratified sample of size 100 from a population of size 500, two strata, then how many sample units are to be drawn from each stratum when you are given with the following information? N1 equals to 200, N2 equals to 300, sigma 1 square equals to 81, sigma 2 square equals to 16. We have to use two theories, proportional allocation and Neyman's allocation. Let's start off with the first one, proportional allocation rule, which is NH equals to small n by capital N into capital NH. Hence, N1 equals 100 by 500 into 200 equals to 40, or N2 equals to 100 by 500 into 300, which equals 60. That is, under proportional allocation, 40 units are to be drawn randomly from stratum 1 and 60 units are to be drawn randomly from stratum 2. Let me clear the screen for using Neyman's allocation. Otherwise, let's continue. B. Neyman's allocation. We have small nh equals to capital N by summation h equals to 1 till L capital NH sigma h capital NH sigma h. Hence, N1 equals 100 by 3000 into 1800, which is equals to 60, and N2 equals to 100 by 3000 into 1200, which equals to 40. And thus our question are solved. Now suppose that a committee consists of 5 members. Number of children of each of them is given below. Now if a random sample of size n equal to 2 is selected without replacement from the above population, then we need to find the sampling distribution of the sample mean x bar. Let's see what the answer will be. Now these are the possible samples. Taking 2 at a turn, we find the sample mean. First 2 1, which comes to 3, and on division by 2 we get 1.5. 2 0, upon division by 2 we get 1. Similarly, we continue for the rest of the values, and this is the sampling distribution table for the possible samples. Now we'll find the sampling distribution of x bar. Let's see what that table looks like. The values of x bar are given on the column on the left and their respective probabilities. We found 10 such probabilities in all, out of which 0.5 had only one x bar, 2 for 1, 1.5 had 3 possibilities, 2 had only 2 possibilities, and 2.5 had only 2 possibilities. Please add them and find out whether your answer is 1. If not, there must have been a mistake, because the total of all the probabilities is always equals to 1. Let's see another diagram. These are the two diagrammatic representation of the probability distribution of x bar. Over here, px bar is taken with respect to x bar. Similarly, we have a histogram on the right side. Notice we plot each and every data independently in the axes. Next, we have a population that consists of 5 members having values 3, 6, 9, 12 and 15. In the first subpart, we need to find a simple random sampling without replacement of size n equals to 2 and find the sampling distribution of the sample mean x bar. For the first one, there will be 5C2, which is equals to 10 samples of size 2 under SRS WOR, that is simple random sampling without replacement. We list the possible samples and find the x bar values in order to obtain the sampling distribution of x bar. These are the all sample values and the all possible values of the sample mean x bar. Similarly, like the previous question, we add and divide by 2. 3, 6 comes to 9, divided on division comes to 4.5. Similarly, proceeding it for others till lastly 12 plus 15 is 27, divided by 2 is 13.5. All the processes has been done in the same manner. We see that we have only 2 9s and 2 7.5s and 2 10.5. For others, the probability is 1 out of 10. Now we list the probability sampling distribution. First, in the left hand side we have taken x bar, and the right hand side we have taken the probability of obtaining that mean. For 4.5, we saw that there are only one possibilities, that is 1 by 10. Similarly, for 6, 1 by 10. We saw there are two possibilities for 7.5, so 2 by 10. Similarly, for 9, 2 by 10. Even for 10.5, it is 2 by 10. For 12, it's 1 by 10, and 13.5, 1 by 10. And upon addition, we find that the total is 10 by 10 or equals to 1. Thus, the distribution is absolutely correct. Let's see what number B asks us. We have also calculated the expectation and variance of our obtained sampling. Now let's see number B, and in that manner C and D will be done. I'll show you how to do number B. There are 5C3, which is equals to 10 samples of size 3 under SRS WOR. I've listed them and also listed the x bar values for each of the samples. That is just like the previous one, 369, and now dividing by 3 we get 6. Similarly, proceeding for the other values, these are the values that we obtain. 3, 12, 15 upon division by 3 comes to 10. Similarly, for the probability distribution function, we proceed as like number A. X bar 6 has a probability of 1 by 10, 7 similarly 1 by 10, 8 2 by 10, 9 2 by 10, 10 also 2 by 10, 11 1 by 10, 12 1 by 10, and upon addition we get number 1, and hence our answer is correct. Just to show you how it will look like when I plot it on a graph, these are the values that have been put with distinct values each with respect to each of the values of x bar. With this, we come to an end of another great video. Please like, subscribe, and WhatsApp or call us for any doubts or for full videos on our courses at the number given on the screen.